Okay, so today we're in math operations with significant figures. You guys have done your bell work already. These are the same significant figures rules that we talked about the other day. Today we're going to talk about adding and subtracting. If you scroll down here, here is the practice problems. We're going to go through some of these practice problems together. So if you would open that link. That should open up a PDF for you. The PDF has all the problems in it. As when we get ready to do problems, I will start with the second part where we're adding and then multiplying and dividing. But right now, I'd like for us to go into our notebook. So if you would please go into your notebook and we're going to get started. If you would like to turn out the light, that's fine. So we're going to get started with math rules. With significant digits. So I'm going to start with just the rules and then we'll start with some examples. So addition and subtraction have the same rules. And what we do with addition and subtraction, the rule says that your answer matches the least number of significant figures in the decimal portion. Okay. So let's do a couple examples of that. Like I said, we are going to do some examples from the practice problems. So I'm going to pull those off the screen and you can copy from the notes here. So 1.421 plus 0.4372. Okay, that's a pretty easy looking math problem that you probably learned how to do a long time ago. So let's add it up. 2, 7, 8, 3, 4, 5. 4 and 4 is 8. And 1. Okay, so here's sort of the new learning. It says that the answer matches the least number of significant figures in the decimal portion. So that pesky decimal is coming back to haunt us again. In the decimal portion. So if I look here, I have 3 digits in the decimal portion. I'm going to just draw a line, and that's where I need to round off the number. So this 2, I can't just chop off the end of the number. I have to round to the place where my significant figures stop. And that's why significant figures are significant, because that last number could have a rounding issue, or it does change the number a little with rounding. So if I have a 2 behind the line, what does that 2 tell the 8 to do? To go up or to stay the same? Stays the same. So my actual answer is 1.858. That's the correct significant figures. Okay, let's do a subtraction example. So when we subtract this example, notice the bottom number has fewer significant digits in the decimal portion than the top. We'll come back to look at this one in just a second, but let's do the subtraction. 2 minus 2 is 0, 1 minus 0 is 1. Okay. So the least amount of numbers after the decimal is right here. And remember, I can't just chop off the number. So is the 3 going to tell the 0 to stay the same or to go up? Stays the same. So my actual answer, 1.010. Give me a thumbs up if that seems easy, and a thumbs down if you're like, what? Okay. All right. We'll have to practice it a little bit, but we want to make sure that we follow those rules every time. And then let's go to multiplication and division, and we'll kind of compare. Okay. So multiplication and division, the rule is your answer matches the least total significant figures. So I'm going to come back up here and I'm going to do the same. I'm going to use the same numbers, but this time I'm going to multiply and divide them so that we can compare what our numbers would be. So, and then this time we're going to multiply. I'm going to click that into my calculator real quick. So 1.421, that's not that number. 1.421 times 0.4372. Okay, so the answer .6212. I mean, clearly we have a different answer because it's a different operation, but let's look at the length of our number. In multiplication process, now we have to count the number of significant figures in the numbers we used. So if we go through those rules for the first number, all non-zero digits are significant. Well, in this case, all 4 numbers are non-zero, so we have 4. In the second number, well, we have 4 non-zero digits, so it's 4 as well. So we're going to end up with 4 significant figures. 1, 2, 3, 4. We're going to chop off the number there. But we can't just chop off the number. What do we need to do? What is our actual answer going to be in this case? Go ahead, Jacob. Right. So this 6 is going to tell the 2 to go up. 0.6213. All right. That one, not the best example in the world because they both had 4, but let's look at this. The one we did up here as a subtraction. We're going to use the same numbers and we're going to divide. So our problem is going to be 1.0123 divided by 0.002. And you cannot see what I wrote. So I'll plug that into the calculator. And 1.0123 divided by 0.002. And I get 506.15. But let's consider in the rule for multiplication and division, the answer matches the least total significant figures. So if I count the significant figures in the first number here, okay, all non-zero digits, so 1, 2, 3, 4, and then this 0 is in between, so it's significant. So I have 5 digits there. In this number, how many significant digits? Show me on your fingers. We just have one significant digit here. So this number, 506.15, has to be rounded off to one significant digit. Well, how do I pick which one? I like all those numbers. You have to pick the number that shows the value that best matches the value. So in this case, it's the hundreds place. We're going to round it off to one significant digit in the hundreds place. Well, what is the 0 in the tens place going to tell the 5 to do? Stays the same. So I'm going to have my actual answer is going to be 500. So interesting, like 506.15 is exactly mathematically the correct answer. But when we talk about significant figures, 500 is the best answer because it matches the significant digits that we have. So that's kind of a weird case. Okay. Okay, give me a thumbs up if that makes sense. And thumbs down if you're like that. It does not make sense. Looking for thumbs. Somewhere in the middle still. Okay. All right. Well, let's do a couple of those from multiplication and division problems from the practice. So this worksheet here that you pulled up from the lesson, we're going to come down here to number 3 and do a couple of these practice ones. I feel like those are just, we're going to look right here at this one and then at this one that combines multiplying and dividing. And then I'll let you have some time to work on your own. So let's do this problem. Okay, well that's not the best problem ever, but 6.450 times 1.010. I'm going to multiply that. So, I mean, this part's kind of straightforward. We're using what we already know to do math. And then we have to apply the digit rules. So we need to count the significant digits in the first number. How many are there? Show me on your fingers. How many significant digits are in that first number? Okay, good. Because the non-zero digits are significant. There's nothing in between, but this is a trailing 0, so that means there's 4. Nicely done. What about the second number? How many significant digits are in the second number? Okay. So non-zero digits, zeros in between, and final or trailing zeros, so we have 4 in that one too. So 1, 2, 3, 4. Right there, we're going to cut off the number, but I can't just chop it off. What does the 5 tell the 4 to do? Go up. So 6.515 is really my answer. All right, let's do a little bit more involved one. 1.23 times 3.4 divided by. All right, so in this problem, this is a math problem you could do very easily, right? Multiply across the top, divide by the bottom. So let's do that problem. We'll do 1.23 times 3.467. All right, so if I'm showing my work appropriately, I should write over. Now, a big point right here is don't round in the middle of your problem. That compounds rounding errors. And if you compound the rounding errors, then you're going to get an answer that's not right and that is just extremely, extremely close. So we want to have exactly right, not just close. So then we're going to divide by 3.96. Now our number, as you can see on there, is a pretty big number, pretty long number. 1.076871212. Now we have to decide what is the best answer. So we go back to our rule. The answer has to match the least total significant figures. So if we look at 1.23, how many significant figures are there? Show me on your fingers. Okay, so there's 3 here. How many are here? I see lots of 4s. What about this one? Show me on your fingers. We got 3 there. So our least total is 3. So I come back to this problem. 1, 2, 3. Here's where I'm going to chop it off at. What does the 6 tell the 7 to do? To go up. So 1.08 is our answer. All right, so this is a really good example of that question. How do I know where to round it off to? You count the significant digits. Okay, so that's going to be kind of your job from here on out with all the math that we do is instead of asking how many do I round it off to, you use these rules for significant digits to know how many to round it off to. So, that being said, give me a thumbs up if you're like, yeah, I can do this. I just need some practice. And a thumbs down if you're like, no, please come and help me. And we got some sideways in there too. Okay, I'll come and check on you guys. But when you look at the practice page that was in your lesson, this 2 and 3 are really the most important parts. Okay, the first one is practicing significant figures again. So truly it should be really fast if you just go through and do it really fast. But 2 and 3 are the part I really need to see that you can do as we move forward. So trying to get that done today. And I tell you what, if you do 4, 5, and 6, I'll give you a couple extra bonus points, okay? Because I know sometimes it's been, wow, that's a lot of work to do. Yeah, it is a lot of work to do, but practice makes perfect. So 2 and 3 is what I really need to see there today. And